All right, writing equations given a graph. So the thing that you want to do here is make sure that you have a good first equation. And the first equation should be the easier to write. So that first equation you're going to write based on the more convenient graph. Here, I'm going to, this is moved down, so I need to find that midline. 3, 4. So from the minimum to the maximum is 4. So that means in between here is just, if I cut that in half, I have 2 units above and 2 units below. Excuse me. So that means that my midline there is at -3. So if you want to make a note, your D is going to be -3 there when you're building your equation. Our amplitude is 2. The height of our curve from the midline is 2. And the period of the function, I'm looking for one pattern or one cycle. So you go midline to midline, getting a max and a min in there. And I think once you kind of draw with a pencil or a pen or a highlighter over that, it's easier to see, okay, this is a sine. So I'm going to write my sine equation first. And the period there is 4. So the whole time, we've been doing 2 pi over, sorry about the bell again, equals the period of our function. Now we're going to put the period in there. I'm going to have to pause for a second while they do it. Here, go ahead and see, do pause as well, see if you can finish that sine equation. I will catch back up with you. Okay. So our little equation, 2 pi over b equals the period of our function, we're going to use that. We just need to solve for b. So multiply both sides by b. So I have 2 pi equals 4b, and divide both sides by 4. 2 pi over 4 is the same as pi over 2. So that's our b value. And we don't need anything else for the function that is convenient. You don't need a phase shift here, since we start right on the midline, right at the x. So our amplitude is 2. That's our A. Our B is pi over 2. Don't forget your x. No C. Our D is -3. Here's the nice thing about this next equation. The only thing that's going to be different is that we're going to have a phase shift. So you can write that next equation. I didn't even look at the graph again. I know the amplitude is the same, I know the period is the same, and I know the vertical displacement is the same. The only work here, the extra work, is the phase shift. So let's do that phase shift work. What you have to decide for your phase shift is, where does it look to you like cosine starts? I like to start cosine at a maximum, so I don't have to worry about reflection. So here's the first maximum I see. And that is 1 to the right. And I like to work this little equation kind of step by step. Phase shift, we always found the phase shift by doing C over B. So C over B is 1 to the right. All right, we already know B, so let's plug that in. C over pi over 2 is 1 to the right. And now we have one variable so we can solve. And since we're dividing by pi over 2, to get C all by itself, we're going to multiply both sides by pi over 2. So my C value is pi over 2. And to make it pi over 2 to the right, I need a minus in there. And those are 2 equations for the same graph. I would put those both in my calculator and make sure they match up perfectly, so make sure they overlap. If you get something that looks like this, you have this graph and then it's like this, it's your phase shift that's off if your graph isn't overlapping. Make sure you're checking things in your calculator. Find a math teacher if you need help playing with your window. That's a very common question, and we cannot help you with that today. Just find Mr. Graham or myself or Mr. Connor today. Okay, 2 more. Again, we need to find our midline. It kind of looks like the midline could be the x-axis, but when I count that, I go up 2 and then 1, 2, 3, down to that minimum is 4. So to get the middle here, it's going to be down 1. So our D value is down 1. And if it would help you to make a fill in the blank, I do that a lot with my kids, with my students. Actually, I'm not going to start with sine on this one. We're going to start with cosine. So for that first graph, make yourself a fill in the blank. And then for the first equation. For the second equation, then all you need is the base shift. So our D is -1. If you want to fill it in as you go, that's lovely. Okay, amplitude. Amplitude from our midline, height of our curve is 1, 2, 3. And the reason I knew that I was going to write a cosine equation first was because on the x-axis, on the y-axis, we're starting at a max. So we're not starting at the midline like we did with the last problem. We're starting at max. All right, period of the function. When we're looking at a cosine graph, we count max to max. So that is pi units. And the way we find the period of the function when we're doing our normal graphing, 2 pi divided by b equals the period of the function. So we go ahead and use that same equation. We're just solving for it. Multiply both sides by b. 2 pi equals b times pi. Divide both sides by pi. So b equals 2. And you're done with that first equation. You're done with the convenience equation. And now we can write the one with the phase shift. So when we write the equation with the phase shift, every piece from above is the same. We're going to use sine instead, but our A is the same, our amplitude, the period of the function is the same, and the vertical displacement. We just have to find the phase shift. So to find the phase shift, I'm going to find a place to start my sine. I'm going to start here. It kind of looks like it's out in the middle of nowhere. Don't worry about it. So I'm going to start here. What happens is, remember, our graphs are always broken into 4. So if one unit here is pi over 2, then half of a unit here and here, that has to be pi over 4, where we're crossing over 3 pi over 4. And pi is 4 pi over 4. So I'm crossing my midline here where I have my dotted line is where I want to start, because then I can use just a 3 instead of a -3. So that's going to be pi over 4 to the left. The way we work the phase shift, the way we get the phase shift, is always C over B. We know B is 2. And now we can find our C. Multiply both sides by 2. And reduce our fraction. Now this one is left, so we need plus pi over 3 here to capture that left. An equivalent graph would be -3 sine of 2x minus pi over 2. And that would get you starting, let me do it red, starting here, that would get the reflection of doing the down curve first. So all 3 equations are equivalent because of how it works. All right, you've almost made it through the practice quiz. We have one more example. This is an awfully pretty graph. This one is challenging because you need a phase shift for both. Don't be intimidated. If you can do a phase shift for one, you can do a phase shift for both. This is a little bit of an extension. I wouldn't expect to see you have to write a phase shift for both for your first equation. But you may have to do it by the time we get to the unit test. All right, I'm going to take a look at amplitude here. I'm counting 4 up and down from the midline. So our D here is going to be 0. With the mess that the rest of this graph is, that's good. Our amplitude is 4. I like to count the period of the function like I'm doing a sine graph. So if I start here at -11 and have an up and then a down, -11 to -1, that's 10 spaces. So the period of this function is 10 minutes. 2 pi over b equals the period of your function. This is all for b. It kind of doesn't matter. Like once you're really comfortable with these equations, the fact that you have kind of a weird graph, I kind of all go the same, weird or not. 2 pi equals 10b, divide both sides by 10, and reduce your fraction. B is pi over 5. That is a weird b value. Okay, we are going to have a phase shift for both graphs. Since on my y-axis I'm not crossing the midline or starting in a max min, I need a phase shift for both. So I'm going to go ahead and make a fill in the blank for sine. And we don't have a vertical displacement for either. And start filling in my blank. So we said amplitude is 4, E is pi over 5, and D is 0. So you can put +0 there on the very end, or you can just leave it. And let's find our C value. So I'm going to start my sine graph out here at -11. So that is left 11 units. And we're going to work that little equation the same as we have for the last two. C over B is 11 units. Our B is pi over 5. And now I can solve for C. Since I'm dividing by pi over 5, I'm going to multiply both sides by it. C is equal to 11 pi over 5. I told you it wasn't going to be pretty. And since I'm moving to the left, I need a plus in the middle there. All right, my cosine equation is going to have all the same pieces, but a different phase shift. So I'm going to use the 4 cosine. I'm going to use the b. I'm going to find a different phase shift, and I still have a displacement of 0. So if you have a 0 up there, you can rewrite it, or I'm just going to leave it blank. And now you can pick where to start your cosine graph. You can start it at a min, or if you're going to put a negative out front of your 4, or you can start it at a max. I'm going to start at a max. And remember, our equations get broken up perfectly into fourths. So I go from a -11 to -1. Halfway in between that is -6. Halfway between -11 and -6 is -8.5. So that is going to be my phase shift for cosine. And same equation. C over B equals 8.5. And our B, again, is pi over 5. Both sides by pi over 5. Now, to get that decimal in the decimal and a fraction growth, you can multiply the top and bottom by 2. For me, I'm not really worried about that. I'm more worried about the trig that you're doing, the trig graphing. So if I was going to give this to you on a quiz, I would skip 8.55 over 5. If you were trying to match something that's multiple choice and you have things as tens, that's where you would multiply the top and bottom and get an extra fraction. All right, that's your practice quiz. I hope that you found these videos helpful, and I hope that you do well on your quiz tomorrow.